Okay, folks, so it's 4 o'clock. Actually, it's like 3 after my time. So that means it should be 6 o'clock some of your times. Anyway, it's time to go. I think we're just about ready to go. I think we've got most folks. Looks like we have 31 folks here. We have a couple of people who are having issues with their cameras, but they can still hear everything. But they're having a hard time being able to get their cameras working. So I'm just going to say we're going to do the best we can because sometimes cameras don't work. I know I've got at least one person sent me a message and said, yeah, my computer doesn't have a camera. I said, well, that's a big problem. So they're working on that. So just go ahead and do the best that you can do. Hopefully everybody's gotten in. We're getting people, and I know people are jumping out too, which is why we keep getting the doorbell, is because we had quite a few people who were like, they crash like halfway through or something. They have to get out and come back in. So no worries. We're gonna get going. So I think we want to start with questions and going over homework from last week. So does anybody have any questions about 1.3 or 1.5 or any of the things that we didn't make any sense, or you want to go over and ask something about either of those really quick?
I had a question about 1.5, the conclusion. I had a hard time figuring out just really the method of doing it without using the MIT app inventor. I ended up just printing the page and cutting it out and placing them where they should be and taking a picture of it. But I didn't know any other way to do that. Didn't think of a way.
I was going to say that's a pretty good option, actually, is cutting it out if you don't want to have the kids build it in MIT App Inventor. I think Josh mentioned last week that he actually built a starter, like a little starter AIA file that his kids could download to do that with. As far as I know, I've never been able to do it without just putting it in App Inventor to do it. So I agree with you. It is sort of odd. I've done it with like the Google Drawing, where I can put in a picture and snip out parts of it and move it around and stuff, but it's not good.
Yeah.
Yeah, I have a couple people for their submission for this week chose to do it with a flow chart, which would still satisfy it, I think, saying where everything would go. A couple people just kind of said this would go in the if spot and just kind of like spelled it out. I did see yours just a couple minutes ago, Stephen, with the cutout pieces. I thought that was a good solution.
Yeah.
And it could be like a discussion with your kids. So you could, like, when you're doing it with your students, you might just say, hey, where would you put this? And just have a conversation. A lot of different ways you could go.
Okay. Actually, on my submission, I initially accidentally uploaded the photo of that in place of my submission at first, and then I went back and put my submission in. So hopefully you saw that.
Yep.
Okay. Didn't know how to take that photo back off, or if I could. So
yeah, once you've submitted something, it just I don't know why, but it just stays there. There's no way to get rid of it.
Okay.
So I know a couple of people had issues with downloading and uploading AIA files because I got a couple of comments on that. I sent you guys an email with a link for a video that I did really quick about reviewing how to do that. Keep in mind that you're going to have to review that with your kids too. Downloading it, don't open it when it shows up at the bottom of the screen. Instead, they have to go get MIT App Inventor and then pull that up. So I'm hoping that helped, at least for a couple of people, to kind of get that working for them so that they could kind of get everything, the starter code working. It seemed like that kind of helped. And then I also went through and did a quick review of 1.3 and 1.5 directions that I sent you guys a video for too. Hopefully that helped. I know some people were struggling with like, okay, they got part of it done, then they just kind of went, okay, now I'm lost, which is oftentimes what your kids will do too. So don't worry about it. But I would definitely go in and maybe take a look at those videos. And what I did is I just walked through the lesson as if I was doing it as I was a kid, and flipping back and forth from one screen to the other. And so you can kind of see how I did it, and hopefully that kind of helps too. So any other questions about last week or last week's homework?
I don't have a question, but I'm looking at the comment for my 1.5, and I redid that and copied and pasted the new picture on there. I don't know why it's submitted with the old picture, but I'll resubmit that. Sorry.
Yeah, you might try to change your file name to just something new. It does happen sometimes where if you use the exact same file name you used before, for some reason, when we try to open it on NetExam, it actually opens the previous submission with the same name.
Okay.
Yeah, it's just, I think it's more of a file management thing on NetExam side than probably on your side.
Okay.
Okay, well, if nobody has questions, okay, so feel free to stop us if you have questions. But so the first piece we went over, so submitting work, it looks like pretty much everybody figured out how to submit work. Were there any questions at like NetExam things? For example, give it a new name when you upload it again. I had a couple of people who were having trouble. They tried to upload something, I think, that wasn't a Word document or that wasn't a PDF. Those are the only two things you can upload, are PDFs and Word documents. And I had someone try and upload something that wasn't either one, and it totally let them upload it, but then we can't open it. So just make sure that it's a Word document. Any other questions on NetExam or any of the how to submit anything? All right, you guys must have it all figured out then. So we are going to start today by talking about 1.6. So let me hop over to Chrome here. There we go. All right, so, and of course my window is huge and in the wrong spot. There we go. Okay, so we are going to go to 1.6, which is called Bug Blasters. So I'm in the student version. I'm in lesson 1, and I've scrolled down to 1.6 right here. And Bug Blasters is interesting because it's the first time you actually have your kids try to fix something that's broken. And at least my kids really enjoy doing that. Like, it's their favorite thing in the world. I don't get why, but they love to be given the code and then they can figure out what's wrong with it. A lot of my kids say it's a lot easier to do that than to build something correctly to begin with, which I think is weird. But my kids love this one and they love to do the fixing of the bugs. So programming with persistence goes through and gives them a really basic sort of what does it mean to be persistent? And it talks a little bit about how a bug is shorthand for an error in a computer code. At this point, if anybody's done Innovators and Makers, they have a whole story in Innovators and Makers about why computer scientists call them bugs. And it has to do with Alice Hopper and she was a rear admiral in the Navy, and she was one of the very first computer programmers, and she and her team were programming missiles. And they had a computer that was like the size of a classroom. It was huge. And one day it stopped working and they had to figure it out. So they started taking apart some of the boards and found a dead fly, or I guess it was a moth, a dead moth inside that was stopping a connection from happening, and it was a bug, so they took it out and taped it into their coding notebooks and wrote a note about, we found a bug in the program. And so ever since then, computer scientists have called them bugs. So it's a fun story to kind of talk to your kids about and give them an idea of how to do debugging. Then they have steps for debugging, always starting with the hardware. The first thing I always tell my kids is, did you reset your connection? And they're like, what? Well, did you? If they're using the emulator, it'll get fritzy on them. They have to go reset it and launch it again. Did you reset your connection to your tablet? So you can either physically reset it or you can sort of cheat. And I'll show you that here in a minute, how to get to do that. But it's just make sure the hardware is working first. Then look for the errors. What kind of error are you getting? So in MIT App Inventor, you'll see red X's and yellow question marks. Red X's are, I'm not going to work. Something is very, very wrong. I am not doing anything. Yellow triangles are just, hey, this might be wrong. I'm not sure. I might run, but I might not. So kind of a warning. And so I ask them what kind of an error it is. What do you see? And then we talk about how to handle each of those kinds of errors. The next one is making sure they understand what it's supposed to do, because a lot of times what they think it's supposed to do and what it's doing are two different things. And I'm like, wait, where's the direction that says it's supposed to do that? Oh, there isn't one. Okay, well, maybe it doesn't need to do that. And so my kids will oftentimes try and make a code more complicated than it is by not going through and very carefully figuring out what it's supposed to do. Making sure code's easy to read. You can collapse code in MIT App Inventor. So just as an example, if I come over here and I go look at some blocks, and let's say for a minute I am done with a piece of code and I'm like, oh, well, I know this works. I can right click and collapse that block, and see it gives you this little jagged here. I can also right click inside the white and collapse all the blocks. I can also go right click and expand all the blocks all at once. So it's an easy way to kind of be able to go back and forth, so you can close something, and this doesn't make a huge bit of difference if you only have a few lines of code. But once you're up into the 200 or 300 block range, you're going to want to start collapsing stuff you're not using just to get it out of your way. And you're like, no, I know this part works, collapse it, move it off to the side. Only have open the parts that you're working with. There's a do it command, a disable command. So in MIT App Inventor, that looks like this. So you can come down to the disable right here, and it grays out that block. So it's no longer running this block of code. And you're gonna say, okay, well, why does that work? Because if you think that might be your problem and you disable it and then everything else works, then you're like, okay, that's where my problem is. Again, you would right click on it and go ahead and re-enable it to turn it back on. Now, do it commands are interesting because do it's only show up now on the purple blocks, which are procedure blocks. So if it's an action block, then it will run the do it command, and it says, in this case, it's an X and a Y, so it's asking for an X and a Y coordinate so I can do it. And notice it put a dot there because that's what my code was supposed to do. But if I click on the actual piece out here, the event handler, so the actual event, there's no do it command. Do it only shows up in a procedure now. And that's different than it used to be. So I can come down here to this procedure and go to do it, and it will bring up the camera for me because I told it to, basically. And now I gotta clear that. There we go. All right, so that's kind of the debugging steps, and always test one thing, fix one thing, test one thing, fix one thing. So your kids like to So the kids like to go through and do like massive amounts of changes all at once. And then they're like, okay, now the whole thing is broken. Yeah, did you test it after you did each change? That's what I always start with asking my kids, is to make sure that they're change one thing, test it. If that didn't fix it, go change it back. Don't leave it changed if it didn't do what you wanted it to do, and that kind of thing, just so they don't get too far ahead of themselves. And then it goes through and talks about some of the debugging features, which I just went over with you. And compilation errors. Compilation errors are errors in code, whereas runtime errors, which are talked about somewhere else in here, runtime errors are when you're asking your device to do something it can't. So for example, if I'm asking it to take a picture of something and my tablet does not have a camera, that would be a runtime error. A compilation error is going to be an error in code. You can also go in, you can also go in and add comments to things, and you can close the comments, you can delete them, you can add and do all of that sort of stuff. So there's your do it command, and you keep going. I know there's a lot it goes through. I like to go through it with my kids with App Inventor open. And then it's going to talk about pair programming. So we are actually going to have you guys work on the debugging, the 1.6 really quickly, and then we're going to step into pair programming. So I'm going to kind of leave that. They have two videos. One explains what pair programming is. The other is from the student's perspective, where they talk about how much they enjoy pair programming. And we're going to talk about that, but I kind of wanted to give you some time to actually work on something. So just as a reminder, we're going to download the 1.6 Study Buddy Fix Me AIA. I'm going to click on it, and because I have like multiples of the same name, I have to add something to my title because otherwise I have a million of them. It downloads. I can't open it from here. I have to come back to MIT App Inventor, and apparently stop messing with that. What did I do? I have no idea. So there we go. Projects, and go to import AIA from my computer. Choose the file, which in this case is that one, and then open it. And hit OK, and now it should open it. And sometimes, depending on what's available, sometimes it will take it an extra couple of minutes to upload if there's a lot of pictures in there or a lot of sound files. So I have my emulator running right here so that you can kind of see this is what it looks like when it starts. And notice it's supposed to be able to draw a line. And I know what it's supposed to do because I looked right here.
We can't see your emulator, Maya.
Oh, that sucks. All right. So let me see here.
I think you're just sharing your web browser right now.
Okay, so new share. Let's see if I can do that. And
There's your emulator only. Yeah.
of course. All right, hold on. How about this? Now can you see everything?
Yep.
Okay, there we go. Okay, I fixed it. Well, not really, but still. Okay, so we'll move all of you guys off the side. So here's the emulator, and as you can see, it doesn't clear, it gives me the wrong colors, and it's not drawing a line correctly. Now, if I want to make a dot, I should be able to click and make a dot, and it kind of does, but not where I want it and not in the right colors. I can't do anything with my slider, and take a picture does nothing. So what it's supposed to do is you're supposed to be able to use your finger, or in this case, the pointer of my mouse, to draw Canvas One Drag event handler. I should be able to draw lines on here, and I should be able to tap and make a filled in circle. So obviously it does make a circle, but the circle is not filled in. So I got to fix that. And it does say that the circle should be drawn on the canvas, and you change the size of the circle with this slider called dot size. Dot size does not change the size of the line, only the size of the circle. Yes, you can make it change the size of the line as well. That's something I save for my kids who finish early. So adjust the size of the circle, choose the correct color. I should be able to select the color and get what I'm looking for, which is not happening. And then when I hit clear, it should clear my canvas so that it goes back so all I see is this guy right here. And then taking a picture should bring up the camera. Now, I'm going to do for you guys what I usually do for my kids, and that is, whoops, see, now I have too many windows open, is that I like to show them what it's supposed to do when it's done. And the reason I like to do that is because a lot of times they have a hard time seeing in their brain what it's supposed to look like. So let's see if I can get this designer window and see if this works. So in this case, there's my yellow line, and there's my blue line, and my green line, and I should be able to make a big yellow circle. I should be able to make this bigger and smaller. So I can make giant ones if I want to. I should be able to take a picture, which looks like that on an emulator. And then I can draw on here again. And again, make circles and dots and everything and hit clear and have it come back to where I started. So that's what I do with my kids, is I show them what it's supposed to do, and then I cut them loose to actually work on it. So we are going to give you about, I think it says about 20 minutes or so to go ahead and work on 1.6. So you're going down to the blast the bugs section. You're going to download the AIA file. Make sure you can go through, and it would work best, I think, if one person was sharing their screen and everybody else was either working along or kind of talking their way through it with them. And your job is to try and get that fixed so that it does what it's supposed to do. So, are there any questions about how any of that works? Oh, come on, I'm sure there's tons of questions. No? All right. So let's see now, breakout rooms. So we're going to do breakout rooms that are a little smaller this week, I think. So 3 to 4 people per room. Does that sound like a plan? So when you get into your breakout rooms, what you want is you want to have one person share their screen. You guys are going to work on 1.6. We're going to give you about 20 minutes. Josh and Maxie and I are going to go pop in repeatedly and make sure everything's going okay and answer any questions, unless you have them to ask right now. Okay, I will pause the video. I am now.
Okay, great.
So, yes, thank you for the
You're welcome.
reminder. I always need to be reminded. So we are back to recording. And so hopefully everybody got their stuff working pretty much and got their lines working and got their picture to come back. Were there any other questions that came up? Okay.
Awesome.
All right, Josh, you want to introduce us a little bit to the next section?
Yeah, so we are going to talk about paired programming a little bit. We've had issues both times trying to get the videos to actually play the sound through what we're doing. So they are worth a watch. We're not going to do that right now. They are worth a watch though. What I would do if I were you is preview them, decide if it's something you want your students to see or not. I always show it to them. They're pretty short. They're just a couple minutes. Basically, the 2 roles in paired programming that Project Lead the Way uses, which are the driver and the navigator. The driver would be the one that's physically moving the code on the computer using App Inventor. The navigator would be there to kind of like talk through, okay, this is what we're going to do. We need to find this. Oh, and you find that over here, and kind of help with the troubleshooting pieces. And then kind of talking about switching roles, like how often should you switch roles? Each student should get to do both roles. And some of that's a little bit fluid, and we'll talk a little bit more about that later, but just kind of an introduction to what those are. So what Maya and I are going to do now actually is, in case you haven't had a chance to see it yet in action, we're going to demonstrate driver and navigator for the beginning of the Germ Fighter game, which is part of activity 1.7. And I will share my screen. I'm going to do the right one this time. So you should see on my screen, I'm on 1.7, the Germ Fighter game. And looking at the design requirements, these are kind of at the beginning of lots of apps, lots of activities. Just make sure your students know what the purpose of the activity is. So this one, we actually are going to make this Germ Fighter game, and there's the design requirements. When we get to it, which we're not yet, but in case you guys are a little bit ahead, when we start to talk like activity 2.2 and 2.3, it provides them with the design requirements at the beginning of activity 2.2, but they're not actually building it until 2.3. So just make sure that they don't try to build something from scratch on some of this stuff. It tells them what it will eventually do, and then it helps them build it. When you get to the projects, it says, this is what it's supposed to do, now do it. But for the activities, it does a better job of walking us through. So if Maya and I were looking at this, and I was assigned the role of the driver, or we rock, paper, scissors, and I got to be the driver, or however it's decided that I'm the first driver, this is where we would get. And step 1 says determine who will start as the driver and who will start as the navigator to complete this project. We're going to have a white blood cell, which is going to be located at the bottom of the screen that we can drag. We're going to have a germ sprite that bounces around on the screen. It's going to hit the white blood cell. We're going to get points, and I win when I run out of time, and I lose if it hits the bottom, or yeah, when it hits the bottom.
Okay, so we're just going to kind of demonstrate here. So Josh is going to go ahead and get MIT App Inventor open, and I'm going to walk him through because I'm the navigator. So he's downloaded the Germ Fighter AIA, and he's getting it open. Okay, so Josh, it says we're supposed to have 2 horizontal arrangements. Is that what we have there?
Yeah. Yep.
And one contains score and timer labels at the top, and the one below it says start and reset button, right?
Yep. And I have sound on box also.
Perfect. So it says go ahead and connect the app to the emulator so we can test it.
Now let's cross our fingers on that one.
And that's what you do as drivers and navigators. So, yeah.
All right, so I got that part.
We'll see if that opens.
It's fine so far.
Okay, cool. So it says from drawing and animation drawer. So first off, does it work?
No.
Okay. So from the drawing and animation drawer, it says we need to drag a canvas component and drop it between the 2 horizontal arrangements. And it's kind of got like a little animated thing that shows it. So drawing and animation, yep, we want a canvas. And it says between the two arrangements. So I think it's supposed to be up. Yeah, right there. Perfect. That looks just like it does on the directions, so we're good. And we need to set some properties for that. So it says our background color needs to be red on that one, on the background of the canvas one. And its height needs to be 350 pixels. And width says fill parent.
Pixels.
Oh, did you put it in as percentages?
Yeah. Oh, and I did them backwards too. No, did I do them right? Height and width?
Height
Okay.
is 350 and width is fill parent.
Oh, filter.
So
Got
you've
it.
got it.
Perfect.
There you go. So that looks pretty much like it does in the directions. And that says from drawing and animation, let's go ahead and drag an image sprite over on top of our canvas somewhere. And it says we need to name that. And so we need to name it by what it is and what it does. So we need to name it white blood cell sprite. Perfect. And it looks like the bell's about to ring. So I'm going to need you to download that or save a checkpoint so that you can give it to me so I can be the driver starting tomorrow. So notice what he's doing is he's going to export AIA to my computer. It came down, it's exporting it down there at the bottom of his screen, and then he's going to be able to send that to me.
And so what I might do probably is I might rename this so that we know. I might call it, what's the date today? That's 9/3/09/03. Just, or some form, so that way when I have multiple of them, I know which one I'm sharing with Maya. Maya, how do you want me to share this with you? Do you want to email, Google Drive?
Email will be easiest.
Okay. Oops. Attach.
Perfect. Thank you, partner.
You bet.
And I just got a ding saying I got the email. So that is a quick example of how you do the driver and navigator for pair programming. Now, I know some of you are going to be like, hey, wait a second, my kids aren't going to want to work together. I got to tell you, my kids absolutely love working together. And they absolutely hate being the driver or the navigator for long periods of time. And so I set a timer for my kids. Every 5 minutes, I make them switch roles, driver and navigator. It also has switching built into a lot of the assignments, so you can follow that way as well. But my kids like to switch really frequently because while they can sit there and be, in charge of the computer and everything for 5 minutes, my kids don't tend to have a lot of coding experience, so they really like to switch it. So they're like, okay, now I'm just in charge of the directions for 5 minutes, and then we'll switch back and I'll try again, sort of thing, because my kids aren't necessarily real confident when they start.
Mm-hmm. So then with that, the process of downloading the file and sharing it with them probably doesn't make much sense at that point. So what I have my students do, so it's not this whole like 2, 3, 4, 5 minutes of downloading and uploading, they would actually physically stand up and switch seats. So they would be sitting in front of a different computer. So if they're on their own like school issued device, they would just have to share their school issued device, which could technically be a violation of their agreed upon thing, but my IT department's okay with it. And I just let them know like, hey, somebody's going to be using it But we have, in my room, we're in a lab, so we just use the lab computers anyways. But just make sure that if you have any concerns, that you tell your IT department that somebody else will be using their computer in my classroom, but it will be under my supervision, so they shouldn't have any issues with that.
Quick question.
Yes.
What do you do if you have an odd number of students?
Most of my students are odd.
I was going to say it depends on, I use getting to work by yourself for some of my kids as a carrot, because I have a couple of Asperger boys who hate working with other people, and they'll do it if they get the carrot of, hey, if you do a really good job this time, next time you can be the one person who works by themselves. I can sometimes do that. Sometimes I also just make a group of 3.
Mm-hmm.
I use groups of 3, especially if I have IEP students that are really not very good readers, because there is a lot of reading. So I'll use a group of 3 in that situation. And I have also used groups of 1. It just depends on, you have to be really fluid with it. I mean, driver navigator is perfection and it's nice, but you just have to be fluid with it.
Yeah. When I kind of do the same. Sometimes groups of 1, sometimes groups of 3. I have some like Google Docs where I'm asking for like some submission items from them, maybe answers to some questions. Some of them follow along with like the activities. Others of them are questions that I've added, or I've taken some questions out of the activities. So if I have a group of 3, what I do to kind of help with that portion is I will have one person pull up the submission document, one person have App Inventor open, and one person have the directions open. So they all have something that they're kind of in charge of. Or if I don't have a specific submission thing, then I'll kind of just have 2 navigators. They'll kind of both be looking at the code and trying to help guide the driver.
Do you sometimes do it to where one of you help as well? Like just to have the instructor being a driver or navigator?
I
Maybe.
have done that with a kid who had a really hard time working with other kids. I've totally been like, okay, I will be your navigator, or I will be your driver today. The problem is you can't really get to everybody else in the room.
Right.
So I don't recommend it as an option, but I have been known to sit there and do that with a kid who's really struggling. And usually once I can get them caught up to the point where they're like, oh, okay, now I get it. Okay, great. Now I'm going to have you go join this other group of 2.
Gotcha.
And a lot of times I will have a group of 3, I'll have 2 of them on App Inventor so that that third person has their own copy of the file.
Mm.
Then maybe someone's absent, then when they're come back, then they can join that person and a file has already been started. Because I mean, we have our gifted students are gone every Thursday, so, and I only have my kids every other day, so you know they'll be missing once every 4 or 5 days. I mean, we have I had a girl that came in at 10 o'clock and she had moved away by 2. You know, I mean, we have a very fluid situation at our school, so I really like to have them more than one person do the App Inventor so that we have another copy of the file started.
Awesome. Any other questions about that portion of it? That was a good question. So if you were to walk into a room, just kind of some like what paired programming looks like and what it doesn't look like. When you have an administrator come walk into your room, they might be a little surprised as to what they see when they're walking into a computer science classroom. A lot of them kind of have in their brains that it's mostly just a student sitting in front of a computer, not talking, just typing away on a keyboard. It should look like some organized chaos a little bit. There'll be lots of talking. There will be students who are hopefully respectfully disagreeing with each other, but there might be some disagreements. If it's silent, it's probably not, paired program is probably not working correctly. So conversations for sure. Students moving around. Maya said maybe once every 5 minutes she moves them. I've heard of teachers who have like a class playlist. And so sometimes it's a 3-minute song, sometimes it's a 6-minute song, and it's just kind of like a musical chairs sort of thing. Anytime the music changes, they switch spots. Some people just do, in certain activities, it says switch roles on step 9, so they'll have them switch roles. I usually tell my students to ignore that, and we just do it manually, either by time or when they feel like they're getting burned out on a set step. Sometimes I'll give them a little bit of fluidity there, and hey, when you get burned out with the coding, it's a little bit cumbersome this time. Go ahead and switch spots on your own. And then if I notice that one student's been doing it for the last 23 minutes, then I'll forcefully make them switch. But strategy-wise, as far as the pairing goes, there's lots of ways you can do it. You can do it based on ability a couple ways. You could put a couple highs together, or you can do a high with a middle. I typically don't go like opposite ends. This person will be frustrated and this person probably won't want to do anything, or will just kind of be dragged along. But a lot of times I'll go like separate them into, okay, like this is kind of a grouping of students. I can maybe go up a grouping or down a grouping for a certain student. But I would never go from the very high to the very low unless, well, that's not necessarily true. Very rarely, unless you have that student that's really, really good at helping somebody else and doesn't just do it for them, but is good at explaining and asking questions and is patient, which there are a few middle schoolers like that, but I would say they're relatively rare, but they exist.
Yeah, I would agree. Matching a really high kid with a really low kid is a recipe for disaster in my room.
Yeah. I have been known to put the two highest together, and then they just take off and do all the extras.
Mm-hmm.
I think that works pretty well.
Yeah. Yep. Especially like if you have, so some of the programs, there's some extension activities in them, and they can really go above and beyond sometimes. And it is kind of neat to see what they end up doing when they're all said and done. So I do it differently. You know, 2 out of the 2 out of 3 activities, I probably didn't group them in the same way. Probably did, or I maybe did the same grouping twice, but then the third is different or something like that. So that is paired programming. Any questions on paired programming? They might fight you a little bit at the beginning, but I think by the end of it, typically they're okay with it.
I got a question real quick, Josh.
Yep.
I've got 20 kids in my class and I have 10 computers, and so I've got 1 computer per pair. Does the pair programming work okay in that situation?
Yeah, I would say that's what I had 2 years ago, and it worked really well because what I did was I had the kid who was supposed to be doing the directions bring it up on the tablet itself. And so I had them log into my PLTW and have the directions open on the tablet. So they were both reading the directions and doing the testing on the tablet. And then the other kid was on the computer doing the programming with MIT.
Okay, yeah, that's a day, and I just had one of them with the tablet, one with the computer, the one with the tablet just had the, you know, had the, I went blank, what's it called?
The companion app?
The companion app, yes, open, and they didn't really have a lot to look at. It was just kind of at the mercy of the other person on the computer as far as directions were concerned, but I didn't realize, I guess I didn't really think about having the PLTW website open as well as the companion, so. Okay.
Yep. Another option, if you didn't have, because some people are running emulators only, so if you didn't have the option for the tablets, you could print off directions. There is a PDF version of the course. And if you were going to do that, I wouldn't print one for every student. I would probably print like a classroom set of directions for everything, maybe put them in a binder or something, in some paper covers or something so that they last a little longer. And they could go through it that way. You'll lose some of the, like, You won't see the drag and drop feature, or, you know, like the GIFs and stuff that you would see on the interactive course, but at least it's an option for something for them to be looking at.
Okay.
At the beginning, I started to do the tutorials for my students, and I made both students do each role. I made them do driver and both, whatever the other one was called.
Navigate.
Navigator. I made them do both, so they both have each one that they practiced on. And so I've just had them in pairs from the beginning because I thought that's what I was supposed to do. And it's worked really good. They've not complained. Now I have some odd numbers, so I do have some kids that are by themselves, but I make them all do all of it. But I guess as we get further along, it'll be harder to do that. They'll need to break up and do their. So can they work on that together and only do it in one of their, like pair that app together, but they both get credit for it?
Exactly, and that's the way I grade it, is that I go around and I come to the group and I say, great, your app's done. I test it. Okay, great. Then I mark them both as complete for that. And then they each have like an individual Google Doc with conclusion questions or something else that they'll do independent of each other. But I grade the completion together.
Yeah.
And I would agree with you. I start them with pair programming in 1.3.
Okay.
I don't wait till 1.6. I do it at 1.3.
Okay. No, I didn't know. I've been doing that from the beginning because I didn't have a clue. We started before we started the class, so I didn't know.
Hey, that's what works. Honestly, kids like the pair programming, and it does.
Well, and I have really small classes because we're getting it just started in our school, and so I wasn't sure. We didn't know, so we just thought it would be easier to do it this way. So.
Perfect. All right. Well, I'm going to share my screen again. I'm going to give you a quick intro. Do you see my data variables screen?
Yes, we do.
A quick intro into the variables section, and then you're going to have a decent chunk of work time again on 1.7. When you're looking at variables, there is a video on this as well, but again, for, well, two reasons. For the sake of time, and also you're likely not going to be able to hear it come out of my computer anyway. I'll just kind of talk through a little bit. There's three types of variables. Well, technically, well, for now, there's three types of variables. There's texts, there's Booleans, which are true, falses, yes, nos, and then there's numbers. You actually have been using variables without even knowing it so far. The set measles button dot text is in itself a variable. It's a variable that is a text that's stored in this button. Likewise, enabled, I think you used somewhere, maybe, or maybe you will be using it. You'll definitely be using it for the sound in 1.7. That's just a true false. That's a Boolean type. And then there's numbers, which you know what numbers are. And so when you've actually been setting sizes of things, those are actually variables. They're just coded a little bit differently. When you get into things like scores and stuff like that, which you'll get into in 1.7, those will show up as a variable command. It'll be an orange block, and you'll be setting things that are called global variables, but you have been using them. Project Lead the Way introduces something called tracking a variable, which is basically just a 2-column or 3-column, depending on how many variables you have, or 1 column if it's only 1 variable. It's a way to see where your variable is now, and then what it is in the next step, and then what it is now in the next step as you go through. So one of the confusing things for students is when you are doing things in computer science, it literally goes one line at a time. So this first line in this algorithm says x equals 0. That's the only thing that I know. So when I look at this code tracing table, or code tracking, tracing table, I know that x is 0, but I don't know anything about y. So your students are going to want to put something here, but they can't put anything there because they don't know anything. Then the next line says y equals 15. And then I do know something about x. It's still 0. So I put a 0. Now I know something about y. It's 15. Then I go to my next step. This is called an assignment. These are all called assignments, but this is an assignment where math-wise, if you show this to a really strong math student, they might look at that and think you're crazy because there's no way that a variable can be 2 more than itself. But really what it's saying is my new x value is my old x value plus 2. So my new x value is my old x value plus 2. And y hasn't changed because I can only do 1 line of code at a time. Oh, I messed something up, didn't I? There it is. And then lastly, my new y variable is my old y variable plus my x variable. So my new y variable is my old y variable, 15, plus my x variable, which is 2. Yeah, good. Maya has a good point there that x's and y's are a little bit confusing when you get them mixed up with math. So things like dogs and cats or some other thing other than x's or y's. I'm just using the ones that were given in Project Lead the Way as I'm going through these examples. This one is a simple 1 variable. So it says first assignment, x is 5. Then I just reassign it. So I'm not doing anything other than saying, nope, x isn't 5 anymore. Now it's 12. The third one, oh, I have a different type. It's what it is now is what it used to be, which was 12, plus 1. That's 13. And then lastly, oh, I'm just setting it to 1. So your students might get confused and think that equals doesn't, the equal sign doesn't mean equals like it does in math. It means is assigned to. So I'm assigning x to 1, or I'm assigning the variable score to 100, or I'm assigning the variable lives left to 3.
I use the word set a lot because in MIT App Inventor, they call them setting a variable or setting something because you have setter blocks and getter blocks. Those are those green ones. And so I tell my kids when you see equals, you're setting x to 5 and you're setting x to 12 and then you're setting x to be whatever x was plus 1. And that way you're kind of using the same vocabulary that's in MIT App Inventor too.
Mm-hmm. Good.
I don't think I'm on mute though. Oh shit.
Nope, you're not. The next one is another example. This time it actually goes through a flow chart. So instead of just saying, here's all my assignment statements, now we're going to follow through a flow chart. So it says set x equal to 10. So x is 10. Here's the biggest mistake your students will make on this one. They'll read the next block and it'll say set y to 5. So they'll put a 5 right there. But remember, they can't do that because in the first step, I don't know anything about y, so I have to leave that blank. Second step, set y to 5. Now I can put something there. It's 5. Do I know anything about x? Well, if I don't know anything new about x, I only know what's old about x. It's 10. For some reason, I ask my students this. I don't know if they just get confused on the less than or greater than sign or what the reason is, but they go the wrong way in the flow chart oftentimes. It says, is x smaller than y? Is 10 smaller than 5? The answer is no, so I need to go this direction. It says, my new y value is my x value, which is 10 times 2, so it's 20. I don't know anything new about x, so it's still 10. And then last, x is 30. Do I know any? I don't know anything new about y. It's 20. So I actually provide a table for my students, a blank table with x and y, and they know they have to have each of these rows filled out, and this box has to be blank. So they'll try to leave it, try to not leave it blank. And then when they don't leave it blank, they'll end up with a row short. And then they'll come over and say, well, I didn't use all the rows. Why didn't I use the rows? And I'll say, well, that's why. And then they'll have to kind of refigure, or they'll try to do, oftentimes they'll try to do 2 steps in one. So they might actually end up with just, they might end up with that because they did these 2 steps at the same time and then those 2 steps at the same time. But you cannot do that. And then I would talk through computers do things one line at a time. Granted, they're doing it so fast that you don't realize that it's only one at a time, but if you were able to step down through the code step by step, it would be just one at a time. And then the one that's the hardest for the students is this one. This one uses words. It uses a flowchart again. Again, I need to go through and only do one piece for the first one. Let me go to the actual task here. They miss this line of code more often than not if I don't remind them. It says track the value of the variables summer weather and temperature, or in temp, in the algorithm shown below, given, here's the important part, the outdoor temperature sensor reading of 65 degrees. So when it says this block right here, set the temp to outdoor temperature sensor, that number is 65. They'll miss that direction. So I can't put it there, but I can put it there. And I still know something about summer weather. I know that it's unknown. So step 1, summer weather is unknown, that's it. Step 2, the only thing I'm changing is the temp. This has to stay the same. Then I ask a question. Is this number greater than 80? Nope. Is this number greater than 70? Nope. Is this number greater than 60? Yep. If it's greater than 60, I change this to mild, and this doesn't change. So it is a little challenging for the students as they walk through this. They oftentimes, like I said, want to try to combine steps together. But if you give them the framework, it tends to help. And then you can even do, if you want to make up an example of your own, something that has 3 or 4 variables, and then they see as they go through, each time they're only making one change to each row. So if you have 3 variables, the first row only has 1 filled in. The second row has at most 2 filled in, and the third row has at most all 3 of them, but it might not if you only modified 1. So, questions? That was pretty quick. Okay. What you're going to do now is we're going to put you into breakout rooms for a decent portion of the rest of the time. All we have left after the breakout rooms is to kind of debrief, talk about the homework. Your goal is to get as much of 1.7 done in this germ fighter game. So in your breakout rooms, you're going to want to approach it a lot like you probably did the Study Buddy app, where you have one person kind of pull up the code on their computer, and then the group members try to help with the navigating portion or try to help get the coding completed. It does a pretty good job of telling you where you need to put things. It gives you the property tables to fill in. Then, we're setting the images. And then down here is the controller. So the controller layer, that's where you're actually doing the coding for what's going to happen. So I tell my students, when you're filling in these event handler descriptions, go back to look and see what it was supposed to do. So what's supposed to happen when I'm dragging the white blood cell sprite? Okay, so if I go up here, white blood cell sprite, oh, I can drag it left or right. So it should be following my finger across the screen left and right. What's supposed to happen, I passed it. What's supposed to happen when you click the start button? And there's going to be a couple of things. You're going to have a timer, you're going to have the germ sprite supposed to be moving, that sort of stuff. What happens when the timer reaches 0? Okay, and then all of the things that are supposed to happen when the timer reaches 0. It walks you through coding the start. Oh, yep, go for it.
I was just going to say that's an easy one. A lot of people will skip. I recommend not skipping that and actually doing that with your kids. And I sit there and go through all of that before I let them start coding. So I let them all do the designer stuff in one day, and then the second day I make them go through and do the table with me in their notebooks, and that eliminates a lot of their problems, is because now they've actually written down what is it supposed to do, and so they're like, oh, okay, I got it.
Mm-hmm. Yeah, because if you don't write down what it's supposed to do, a lot of times when you'll code when it reaches 0, but then you'll miss things. Like when it reaches 0, it's supposed to like play a sound, and it's supposed to show a you win background, and it's, you know, all of the things that it's supposed to do, and you might just say, oh, when it reaches 0, it's supposed to stop. Well, then you're gonna miss some of the things. But the start button, it walks you through. It talks about heading, so it's speed, intervals. This is one of the things that I mentioned earlier. Another thing that kind of drives math students a little bit crazy is that X is just like you would think it is, low X value on the left, high X value on the right, but Y is upside down from what a math student might think. It's 0, 0 up in this corner, and as you go down, the Y values actually get bigger. So they struggle with that a little bit sometimes.
The kids will definitely struggle, and I try and liken it back to the old style TVs on the old CRT monitors and TVs. It scales the picture from that upper corner, and that's why it gets bigger and smaller that way, so it can scale from that 0, 0 in that upper corner. And so it works that way on your tablets too, just because that's kind of the standard for how they did it when they started making TVs.
It talks about the reset. Again, it's got a lot of the blocks filled in here for you. But as you're looking through, so there's questions like this. And they kind of are little trick questions. Anytime it's asking you something like this, it usually means there's more left to do. So what happens, why, what other actions? If it's ever asking you that, there should be more. Or a lot of times it'll say, did it work as you expected it to? It's almost always no. Unless you're ahead of the game, the answer is almost always no to that because you're not done with it yet. And then pay attention where it asks for, kind of getting a little bit ahead here. So here's the variables. So I don't think you probably won't get this far during our time today, but here's the variables. At some point it says, here's a flow chart. This flow chart's really important. Test your app to make sure everything's working appropriately. If there are any errors in the behavior app, read through and fix it as you need to. So, like if you don't have a label that updates, for instance, that needs to be addressed and fixed. So that it's probably a little bit above where you are right now, unless you're already through this. But just make sure that anytime it says to test your app now, and oh, here it is. This is what I was looking for actually. Test your app now and make sure the label updates properly. There's two parts to this. You're updating a variable, which is just kind of a thing in the background, and then you're updating a label, which is something that's shown. So just make sure that you actually go ahead and test your apps. And I'm going to debrief a little bit more on that sort of stuff in general after you guys get back from your breakout rooms. But just want to give you as much as possible for those of you that are maybe have already started this, so that you have as much information as I can give you right now.
Okay, folks, so I've got the breakout room set up to break you into 2 or 3, and I'm gonna pull you guys back at about 5:50, if that's okay, because we want to go over the homework and what needs to be on the submission documents. So you should get a message, and now you can head to your breakout rooms.
Do you want us doing driver and navigator for this, or is it
Ideally,
just like
yes.
survival? Okay.
Huh. See, this time I remembered to turn on the recorder.
Yay.
Yay! It's a party. Oops. course I did. No, what is that?
All right. Looks like everybody's back. We're going to take a little bit of time just to talk about the homework that you have coming up, and then we'll stick around for a little bit if you guys have questions on what you've done so far on 1.7. But we want to make sure we can get you guys out of here on time if you are feel pretty good about 1.7. I know it wasn't a lot of time to get working. You maybe got through the designer and just a little bit of the code. I do have a couple things to point out about it again, a little bit more specifics, but
Can I ask a question?
You bet.
Okay, we had trouble getting the image to change, and I didn't know if anybody else had that trouble or not, if that might be something that you might want to cover as a whole. We could
like after you put the text box in there, it didn't change anything?
No, whenever we got to, when we were changing, you know, on Canvas 1, you change it to white blood cell sprite and germ sprite, and you have to go down to media to find your image. And I would upload the file, but it never changed it on the desktop. Is it supposed to change it where you see what looks like a white blood cell or germ sprite on there?
Yes, when you change your source, you should.
Right.
So we had it selected on there, but it never changed the image.
So when you're looking here, you uploaded a file.
Correct.
Well,
Did you change?
It's already there. White blood cell white blood cell PNG is already in your media drawer.
Yeah. Did you change where it says picture?
No.
Did you change it to?
Nope. That's probably where it was. Okay.
Yep. That's a really common, especially for sounds. For a lot of times the students seem like they remember the picture one, but they forget the sound. So when you're doing sounds, it's kind of the same sort of thing. It'll be like a source file for your sound, and it'll be the same thing.
All right. That's all it is.
All right. So homework for 1.7 is, or part of 1.7, excuse me, let me start over. Homework for concept assignment 2, part of that is finishing all of 1.7. So you need to go through this whole thing, and there's a couple places, again, to point out, and one of those is the clock. So I'm going to go to the clock, which is like step 50 or so, if I remember right, the timer. Okay. Now this is, I mentioned it in passing as we were going through. You definitely want to look at, and you'll definitely want to have your students look at the flowcharts, because that's what basically tells you how the clock should be coded. So whenever the clock component ticks, decrease by 1, update the label, check to see is it 0. If it is 0, I'm done. Show the message you win. Check to see if there's sound. If there is sound, play the sound. Okay. Maya has a video about clocks that she's going to post for you. So if you're having a little bit of trouble with the clock, you'll be able to view that as a resource. Check for the timer enabled. There, it talks about that in step 53 to uncheck it at the beginning so that it only starts once you've done it with the start button. There is a part where you're going to need to think about when you get to the end, if you are having a few bug things, the timer might continue to go forever and ever and ever and ever. So you have to think about how am I going to make it stop, because it doesn't make sense to have negative 20 seconds of clock left. So that's something you'll have to consider as you go through here. Any other like pointers or anything as they go through 1.7 that you can think of off the top of your head?
No, I think you hit all the big ones, but one last thing is it does ask them to answer the activity 1.7 conclusion questions in the submission assignment. So those are the 2 conclusion questions down there. And they could have just copied and pasted that text into there, but they don't. So essentially what they want you to do is to answer those 2 questions on number 4 in your concept assignment. So just if you're wondering, what do you mean the conclusion questions for 1.7? They mean from the student guide.
Yep. Good. Couple homework things in general. I just kind of, over the last couple of weeks, I've been putting down a couple things like common things that people have been having issues with. So I want to make sure to hit those as well. So for homework, complete 1.7, all of it. On NetExam, there is a resource, formative assessment, teacher resource, question strategies. Those would be found in the 1920 app creators. And eventually this will load, maybe. We're in week 2, meeting 2. So here's the teacher as a facilitator, the art of questioning, building your questioning skills, formative assessment. This building your questioning skills assignment, that is on our plan for week, I think it's week 8. I wrote it down somewhere, I thought. Week 8, building your questioning skills is due week 8. So it's just kind of a preemptive, hey, you should look at this and start thinking about it. I believe it asks you, let me open it up and see, remind myself what it is, building your questioning skills. I think it's gonna ask you, yeah, so you're gonna gather some data. So this is something that's due in week 8. So if you don't open this until week 8, you won't be able to participate in the discussion where you were supposed to have gathered some data and examined some data. So I do this for this week, read through this and start to think about the places where you're going to gather this data. So it says determine an instructional period, 20 minutes or 20 minutes or more. You can record it, or you can have somebody kind of script you or something. Basically, you're looking to see what types of questions you're asking. And then you're going to examine that data a little bit. Complete and submit concept assignment 2. Here was kind of a common theme that's shown up. Make sure when it's having you complete the activities that you actually follow through on the student course. So it's not something where like, hey, build this app, and then you just have to try to figure it out on your own. The student course does a pretty darn good job of leading you through the beginning. As we start to get a little bit further, it will do less and less of that for you. Maya already talked about uploading to App Inventor again today, so I'm not going to go through that. Just remember when you're turning things in, basically it's like a pass-fail or a meets expectations or not yet, or however you want to phrase it. If you don't do it all, we have to send it back. And if it's not right, we have to send it back. And you can't be marked off until it's all done and all right. So things like testing your app, make sure that you do the coding and then test it to make sure it works. If it doesn't work when you test it, maybe think about revisiting, debugging, asking a question, something, because for sure, if you turn it in and it doesn't work, it's going to come back to you. So just a couple things to keep in mind there. And then I put this on here. We don't really have, like, other than due before our next meeting, other than that, like, sort of due date. But just kind of remember that if you turn it in, the later you turn it in, the less time you have to work on revisions. So if you turned it in 5 minutes before class started, and then you need to do revisions, then basically you have 2 assignments to do now. You have the new assignment plus doing the revisions for your old assignment. And then, that can kind of back up on you. So my recommendation is to not save it for last minute. I know we all have other jobs, and there's things, life, family, schoolwork. We had a holiday weekend.
Hurricanes.
Hurricanes. But if possible, I would try not to save it for the last minute. Otherwise, you might get a little bogged down. It's not too bad if you do a little bit at a time, but if you have to sit down and do multiple hours worth of it, it can get pretty frustrating pretty quickly. So that's that. Any questions, comments, concerns, anything for the good of the class? Stop sharing my screen. All right. If you don't have any, Maya, anything else for them?
I did have a couple of people who decided that they're having issues with their tablets and they want to try the AI starter and the emulator, but
Mhm.
they have had trouble getting it working. So I will send that link out. At the
Mhm.
same time, I'll send an email that also has the link to that clock video. And it's just a really basic how to get a clock working. Why do you put this here kind of thing. So hopefully that will help you, and I'll send those out probably tomorrow morning.
All right. Well, if you have questions you want to talk about, you're free to stick around. We'll stick around for a while. If you don't, it is 8:02 my time. So we've earned back 2 minutes that we let you out early a couple weeks in a row. So